Welcome to clickmyproject.com. Our product title is Single Phase Inverter with Energy Buffer and DC to DC Conversion Circuits. Now we discuss about our product abstract. In our process, the proposed inverter pulse width modulations techniques for DC to AC and AC to DC conversions and control techniques for DC to DC conversion circuit using the PI controller and PWM process. The energy buffer circuits and the H bridge circuit are the operation according to the using mainly for PWM techniques. The output following the voltage command signals and control of the DC to DC conversion circuits. So the circuit charge and the capacitors enable of the cooperation of the PWM process. The proposed inverter can be reduce the voltage harmonics level and the DC to DC conversions current in comparison the remaining the conventional inverter process. It consists the DC to DC conversions process. H is mainly the inverting output the current low total harmonic distortions with higher efficiency of the conventional inverter, and further features for the contribution of the circuit volume and increase the device of level in the number of capacitors and resistors levels. The energy buffer circuits, H bridge circuits, the operation according to the PWM techniques with the DC to DC charging of the PWM. So we consist the energy buffer circuits have the 4 switches and 4 diodes and buffering capacitors. The inverters can reduce the voltage harmonics level and conventional encode comparison with the use degrade of the performance and leakage current also and reliability inverting process. So mainly we focus the inverter 3 stage of the switching and control the energy buffer level. So firstly we designing for that energy buffering and circuits with the combination of the inverter we can use the H bridge circuits level, and we introduce the PWM pulse width modulations converter for DC to DC conversion circuits. Now we discuss about our product flow diagram. So in our process mainly we focus the few models of the process. So first model for the input source. So in this block we structure the made up the 3 models. So model 1 we conventional H bridge circuits, and we utilize the switches and generate the maximum and minimum voltage level to the line to line waveform here. So the bidirectional switches and each response for the each phase, and it sends a normal mode and exclusively employed the particularly phase for the bidirectional switches and then connected to the DC source in the input process. So after we give the some energy buffer circuits, here we can use the 4 type of switches. So we using the IGBT switches. So in this process the buffering circuit we use the IGBT circuits, the energy buffer circuit, the H bridge circuit, and operate the according the PWM techniques. So in the following the voltage command signal and circuit have 4 switches and 4 diode and buffer capacitors inbuilt the buffering circuit. In the capacitor is the positive voltage of the process. The circuits positively and negatively superpositions and supply voltage set the DC link voltages of the 3 level of the depending on the state of the signal switches. So buffer capacitor change the DC link current, and the conversion of the consists of 2 switches and 2 diodes and chopper inductance for the operation to the constant level. So we mainly use the IGBT switches. So in the IGBT switches for using the cross between the conventional bipolar junction transistors and field effect transistors. So both ideal semiconductor devices and switching the make best part of this 2 type of transistors, the high input impedance and high switching speed, the IGBT switches, and we using the mainly the H bridge circuits. In these circuits the commonly use the inverting process and single phase bridge inverters, and the DC supplies will generate the square wave and voltage waveform across the load. The waveform would be the triangular waveform, and depending that inductance and switching frequency levels input voltages. So on the off or controlling bridge and low side switching devices, one side the bridge rectifiers and switching devices, on the opposite replacement of the diodes. So and then finally we go into the represent the DC to DC conversions. The electronic circuits, the device converter source direct to current DC, and the voltage level another electrical power converters. The converters also completely hybrid circuits with use the electrically assembly ideal DC to DC converters with a flat, and the real converters produce the DC output upon with the superimposed some level of the electrical noise. So in this the mainly the circuits H3 circuit and DC to DC circuits conversions and energy buffer. This mainly we focus for the BWM generations. The BWM generations the low frequency based methods such harmonic eliminations and space vector controls. So in the high switching frequencies such multi-carrier pulse width modulations, and present the description of the how to the space vector multiplications and the three-dimensional three level of the integrations result thus auto shaped inductance current. So finally we get the output AC to DC and DC to AC to DC process. They we connecting the voltage for the grid. So grid is the simple we can store the some output voltages in the grid functions. Now we are going to discuss about our product running procedure. In our process we have designed in the MATLAB 2013 version using the Simulink tool. So in this Simulink tool having the Simulink library browsers, we are getting from here what are the components we need, just search and get it from here. So after complete this designing, so overall we can considering the graphical method using the scope method. So just we can design complete the designing, and mainly we consider that continuous power guy is important for this panel for overall power circuit for the Simulink process. Just you can search the power guy, it will be give that so overall power supply for that. So this is the power guy. We can use the continuous waveform process, so overall connecting the power supplies. So after complete this process we can just run this process. See we can monitoring the every output for the scope graphically method. So first of all we give the input for the, so this is the input process. So this is the input for the 100 voltage DC process. After we go into the H bridge output process. This is the H bridge output circuit for this. This is H bridge waveform for the voltages. After we go into that last finally we get the voltage for the current. So current voltage for here, and then we get grid output voltage. So grid output voltage for the scoping the process. So this is for the grid voltage output process. So we can connecting the DC input voltage and H3 circuit and DC to DC conversions, and lastly we connected the energy buffer process. So we mainly with this switching process we using the BWM circuit converter process. Pulse width modulation is a basic the switching connecting for the PID controller, and then we create on and off switching process for each IGBT switches. So everything is completed. We can scope the finally the grid voltage for the DC to DC conversions for the output voltages. Thank you watching our video.